Mm, yeah, Professor.
Good morning. All nine of us, huh? There's not a lot. That's okay. How's everything going? How you feel about Math 33 and Math 111 so far? Week 4.
Yeah, not too bad.
Oh, good. Okay.
I think the only trip up that I've really had so far where I was like, oh man, like I legitimately don't know is was actually on the 2.7 homework, which when it deals with inverse functions, the part where it does you have to solve for two x's. So you have to plug in like the numerator and denominator both has a fraction in it, if that kind of makes sense. So it's like a fraction
Yeah.
inside of a fraction.
Oh, yeah. You're right. That is not easy. It's kind of bad because this class is so much material, and then it's just expected that you remember every single thing from algebra, but maybe you never even learned it before. And uh, it's a lot in this class. There's so much material that we're supposed to cover. It's almost too much, I think. But yeah, the good, I don't know, I can't remember if I told you all, but I think, if you're a STEM major, obviously, then after this class you're probably going to take Math 161, the first part of pre-calc, or there's a pre-calc class that's both semesters. It's shoved into one. Either way, that class, it'll be a lot easier, or it'll be kind of easy compared to this class, because most of the material in this class is all pre-calc material. So it's almost like right now you're paying your dues, and it's difficult. The material is difficult, but next semester half of the class will be review and the rest will be new. So it's kind of,
Yeah. On the track, 'cause I'm on the STEM track right now, but on the STEM track that I've seen, the next class is trigonometry, and then it's pre-calc, then calc 1, then calc 2.
yeah, that's right. So you're right. Then you take trigonometry. That's kind of a weird class. It's a lot of memorizing, so it's not super fun. I was not a big fan when I was a student. But then the next one after that, yeah, the pre-calc Math 162, I think it is. That one is a lot of the same material we're learning, all this algebra stuff and graphing and inverses and functions, all that stuff again. So maybe at least now this semester is difficult, but it'll get easier then because you've already seen it all.
And then the last one I believe is discrete math, but I don't really know what that is.
Oh, that might be one you would have to take if you transfer. I don't think we have that. Do we? Oh no, Math 130. What's that? Is that we might have that, huh? That's kind of a weird one. That's kind of like a lot of the algebra things that you learn. Where could it be used in real life? So it's kind of interesting, actually. So if you have to take Math 130, that's kind of a good one. Yeah, interesting. Okay. Yeah, how'd you feel about, let's see, the section 2.8 homework is not due yet, right? Let's see. It's gonna be due coming up pretty soon, I think.
Yeah, I think it's a Friday or Saturday.
Yeah, okay. So the worksheet we did on Tuesday kind of had to do with that. Um, yeah, and it's probably, hopefully that means that homework, when you get to it, if you already done it, then of course you're fine. But once you get to it, hopefully it'll be easier because you will have seen it and we've done it together, the formula in class. Yeah. So that's section 2.8. That's the last section in chapter 2. And then we move on to kind of new ideas in chapter 3, which that's what we're going to kind of talk a little bit about today. We're not going to get in too detailed about it because of course you're going to see it a lot in Math 111 this coming weekend. Let's see, when is that homework due? 3.1. So we're going to be today we're talking about this worksheet. Actually, I should link it in the chat, huh? Now that I'm thinking about it. Chat. Yeah, it's on Canvas and our week 3 Math 33 week 3 module. But just in case you want it on here, it's kind of going into detail about graphing parabolas. So, the parabola is like the graph of x squared, and then as you add more things to just y equals x squared, maybe there's a plus 5 at the end. We've kind of seen that before in chapter 2 because we did the translations and stuff. So if you have a negative in front of x squared, it'll flip it upside down, the parabola shape. But we kind of, I don't know, glanced or glazed over it. We went kind of quickly. We just did a little bit of parabola stuff, but the beginning of chapter 3 really focuses in on parabolas and how to graph them. So let's see here. Oh, here it is. Finally, I found it. Okay, I'm linking the PDF of today's worksheet in the chat, but it is in Canvas. Oh, sorry. I see you have a question.
For the midterm, is chapter 3 gonna be in the midterm, or is it only gonna be just the first and second?
Oh, good question. I think it'll have part of chapter 3 in it, because I think we're gonna, yeah, good question. Where are we gonna be? In it'll be in week 6.
And would it be a good idea to start practicing for the midterm, like studying on it?
Yeah, you know what? That's not a bad idea. Like if you have a little extra time, you finished your homework and stuff for Math 111 and you're a little ahead, that's not a bad idea. So actually, that's a good point. I'm gonna share my screen. Let's see. Share. Why isn't it working? Yeah, okay. Why is this? Oh, here we go. What? Oh my gosh. Because I was just looking at, yeah, the on Canvas. This is not Math 33, because Math 33 is fairly, straightforward. It's got just the worksheets and that's it. But in Math 111, we're in week 4. So this is kind of what's going on this week. Yeah, we have the 2.8 homework coming up, and then, or actually, April, what the heck? Oh, geez, I'm gonna have to fix that. Oh, yeah. Okay, we have a homework coming up, and 3.1's coming up. That doesn't look right. Am I on the wrong? Oh my God. Anyway, but week 6 is when we have our midterm. But you should see the practice midterm in here. It should be at the bottom of the week 4 or week 5 module in Math 111. So that's not a bad idea to just start looking at that. I mean, if you don't have time, then I think it's going to be fine, because we still have a couple weeks till the midterm. But it's a good idea. Click on it. It's just a PDF and it has a bunch of practice problems. And the week before the midterm, which I think is next week, we'll be going over this. We'll kind of cover all the problems and hopefully, answer any questions you might have and review everything that we've learned so far. So pretty much it's going to cover, in chapter 1, we only went over one section. It was 1.4. Is that right? Yeah, the complex numbers, that'll be on there. And then all of chapter 2, because we'll have finished it in a couple days from now. And then also a little bit of chapter 3. I think the first 3 or 4 sections we'll have done by then. But all the examples that you see in this practice exam, which is linked in the I think it's week 5 module of Canvas. If you look on it, just has all kinds of practice problems. And if you just kind of review these and you know how to do all of them, then you'll be fine for the midterm. Because for the midterm, I just took a bunch of these, not all of them, because there's a lot, but picked a few, like 15, I think, of these problems and changed the numbers around. And that's what the midterm is. So if you can do every problem on this practice exam, then you'll be fine. I mean, yeah, it'll be the same pretty much thing, except for just a little bit. The numbers are a little bit different. That's all.
And this practice exam is available to us on the 111 or the 33?
Oh, the 111, yeah, 111 Canvas. But that's a good idea. Maybe I'll link it in, the 33 Canvas also. Just, yeah, maybe this week I'll put it in there just so you can practice. And like I said,
will there be like an answer sheet to check if our answer is correct on the practice?
Yes.
Okay.
The very last page has all the answers to it. So in this midterm 1 practice exam, there's 18 problems and all the answers are on the very last page here. So yeah, that way you can kind of check. And then also that's probably a good idea. I think before the midterm, maybe if you have a chance, try these whenever you get a chance, try them. And if you have to go back and review, like if you say, oh, I don't remember how to do the complex number stuff, that's normal if you forgot, because we've learned a lot of things and you probably learned things in other classes. So just kind of go back and review maybe, and then try the problems and check your answers, because here's number 1, the answer, here's number 2, and on and on. And then, for example, number 8 is a graph, so you can kind of check your answer. And so all the answers should be there. You can check. And then if any of them, you're not sure why your answer is different, so you're not sure what you did, then we'll definitely go over those the week before the midterm in this Math 33 class. Yeah, because it's.
And when we take the midterm, is it going to be on Zoom on a Tuesday or Thursday, or?
Yeah, it will be. It'll be pretty much just during our class. I have to look at the schedule. I think is it on a Tuesday or Thursday? But it's on one of the days. I'll have to look.
Okay.
Yeah, and then you just log into this Zoom session, and then there'll be a PDF that I'll link in the chat, but also it'll be available on Canvas, and then you'll work on it. Just make sure that you have a video of it, or the camera's working on your computer or on your iPhone or whatever that you want to do, so I can just make sure that you're the one taking the test. Yeah, and then you'll upload it to Canvas when you're done, and that's it.
Okay, thank you, Professor.
Yeah, thank you for asking. That's a good question. So it won't be, you don't have to remember an extra day. Oh, I got to make sure that I come to class on a certain day, the midterm. It'll be a regular class day, so you'll be here anyway. Yeah, but I'm gonna try to remember what day was it? I think it's week 6, but which day, Tuesday or Thursday? I'll have to look. Oh well. Yeah. So I'm glad you guys asked about that. Thank you. That's a good idea. Today, yeah, like we said, this is kind of just starting to talk about chapter 3, the beginning of chapter 3. What we're trying to do eventually in chapter 3 is not only graph a parabola, which is just graphing a graph that looks like something x squared. So I think, let's see, I think you can see what I'm writing here. Y equals x squared. That's one of our favorite graphs that we know and love. It's just that kind of U-shaped parabola graph. Okay. But eventually we're going to want to be able to graph any polynomial, and a polynomial is pretty much just a bunch of terms with x's in them and powers on x and coefficients. So we want to be able to graph something like 4x to the third plus 5x squared. I'm just making this up, minus x plus 7 or something like that. That's not easy because that doesn't factor. And we'll see in this section that we're going to cover today, if it's a parabola shape, if it's the highest power of your polynomial is 2, like this one, then it's going to be a parabola. But if you have a higher power than 2, like 3 or on 4, then it's going to be a weirder shape and it's harder to graph. And we're not able to factor this. So that we have to build up to how to figure out what this graph looks like in chapter 3. That's a lot of it is covering that, not factorable, this guy. But the kind of things that we're going to want to graph in the first section of chapter 3, which they just focus on parabolas, would be, something that actually factors, like, oh, let's try to graph y equals x squared plus 5x plus 4 or something, 5x plus 4. And part of that will be finding x-intercepts, and you can find the x-intercepts by factoring this, factorable. Yeah, so we're going to kind of see in section 3.1 is a preview kind of. We're just going to focus on parabolas where the highest power of your polynomial is 2. And the graphs of them look like parabolas, but maybe they're shifted, like we've seen before, they're up or down, or they're upside down. Maybe they're a little wider or narrower than your basic parabola. And then, yeah, factoring it will allow us to find the x-intercepts, which is important to know kind of where it lands on the xy coordinate system. But then we're going to kind of move that up and say, well, what if it's not a parabola? What if the highest power is not 2? What if it's something bigger, like this guy, a 3 or God forbid, a 4 or 5? And how do you graph those? So I think that's why the first section of chapter 3 has to do with graphing parabolas, just because it gives you the idea, and then we can build on that and say, well, what if it's a polynomial whose power is not 2? It's something bigger. Then how do we do that? Yeah, that's what we're gonna do. So I know it seems kind of early because you haven't, maybe you finished section 2.8 homework, maybe not. But I think we'll kind of look at graphing parabolas and the basic idea behind them, and then the section 3.1 homework, when you do it, will be a lot easier, I think. But that's the idea. Okay, let's see. I'll try to share my screen, not the whiteboard, but there we go. Okay, so this is the worksheet for today. It's not too long. I mean, it seems like there's a lot of problems. We'll just see kind of how many we get through. If we don't finish it as a group together, then we'll just say, oh, we won't do those later problems. No big deal. This is just a lot of practice. So you have every kind of problem available to you. It's all, easy peasy. But let's kind of say what's important to do when you're trying to graph a parabola, because these ones, you could probably graph them a very simple way, I guess, but if you want to get into detail, this is what we need to do. Okay, to graph a parabola. And like I said, in section 3.1, we're just focusing on parabolas where the highest power of your polynomial is going to be a 2. So it's definitely going to have this U shape. It's just the question is, where is it located on the XY coordinate system? How wide or how narrow? Is it upward facing or downward facing? Yeah, but it's definitely going to be that U shape. So first thing I would say is the coefficient in front of x squared a negative or a positive? If it's a positive, then it's going to be an upward parabola, but if it's a negative, then it'll be a downward parabola. So I'm going to go, okay, if the coefficient, you might already know this, so don't feel like you have to write it down or take note of it if you already know it, of x squared is positive, the parabola will face upward. Okay. is upward, so like a regular U-shaped parabola, okay. But on the other hand, if it's negative, like it looks like in example 2 here, I see there's a negative in front of x squared, then the parabola is a downward parabola facing downward, like an upside down U, like that. Yeah. So we got that. Then you can kind of imagine what it looks like. And then the rest of the steps are nailing down where is it located on the XY coordinate system and how wide or how narrow is it. Then from there, I would say the vertex is the lowest or the highest point. Highest point on the graph. And it depends if it's an upward facing or a downward facing one. So if it's the upward facing one, like we drew up here, then the vertex would be this lowest point. It's kind of like where the U shape starts, I guess. Where does it start? That's the vertex. That's what they call that point. And then if it's a downward facing one, then it's the highest point on the parabola. But it's still kind of, yeah, where that shape starts, the base of it. But the vertex, you can find that kind of like we did, in chapter 2, when we talked about transformations of regular graphs, the basic x squared graph, I know what he looks like. It's a U shape that starts, its base is at 0, 0, the origin. But then we've seen before that once you start kind of moving things around, adding these numbers here, then that's going to move it a little bit, either left, right, up, down. But the vertex, pretty much when it looks like these types of when it looks like this, where there's a number in the parentheses with x and it's all being squared, and then maybe there's a number adding or subtracting at the end, the vertex is going to look like you take the number that's inside the parentheses with x and change its sign. Change the sign. So if it was a positive, make it a negative. If it was a negative, make it a positive. In this case, it looks like -4, so I'm going to make it a +4. So that's your x value of your vertex. Excuse me. And then the number at the very end that's adding or subtracting is the y value. And I don't change the sign on that one. So I change the sign of the x value, don't change the sign. It's hard to remember that. The sign of the y value. So I think, I mentioned that when we take the midterm, I think I mentioned on Tuesday that you can have a 3x5 note card or something small piece of paper with notes like the formulas or whatever. Honestly, I think if I were in this class, I was a student, I would have one of these examples kind of written out on there somewhere, or kind of points about it. So I might even write seriously this example and say, oh, the vertex is this and this, just to remind myself if I'm taking the midterm and there's a similar problem, then I'll kind of know how to model it after this one. Because there's a lot of things that's hard to remember. When I find the vertex, I just take the number that's inside the parentheses with x. That one I change the sign, but then the number that's at the end, I don't change the sign. I keep it the same sign. It's kind of hard to remember, but I guess that's the quickest way to think of it. Instead of before in chapter 2, we used to say, oh, well, this is what do we say? The number that's inside the parentheses with x is the horizontal change. And if it's a minus, that actually, you would think it would move it to the left because that's the negative direction, but it actually moves it to the right. And then the number at the end, adding or subtracting, is a vertical shift. If it's a positive, you go up, which is what you would think to do. And if it's a negative, you go down. So this is really just like your horizontal and vertical shift if you were thinking of it in that way from chapter 2. And vertical shift. But it's just easier to just remember it. The vertex is going to be when I change the sign of the x value and I don't change the sign of the y value. And that's it. But that's kind of the idea. We find, okay, we determine first, okay, is it upward facing or downward facing? And then what's the vertex? And here that's kind of just staring you right in the face. It's the number inside the parentheses with x and the number inside, at the end, adding or subtracting. So that's the vertex. And then there's a lot of steps to it, which is why, like I said, I think I would write some notes to myself on my note card. I would say, now you need to find the x-intercept. Where is this thing hitting the x-axis? No matter what kind of function you're looking at, this happens to be a parabola or a quadratic, they call it, function. Doesn't matter what kind you have. If you want to find x-intercepts, you let y equal 0 and solve for x. That's true here, but it's also true for any kind of function. So that's kind of the easy way to just remember that for anything. If you're trying to graph a brand new function that you don't know what it looks like and you want to find x-intercepts, just let y be 0. And then the same thing the other way around. If you want to find the y-intercept, by kind of the opposite, I want to let x equal 0 and then solve for y. So it's a lot of work. All these guys are a lot of work. but we'll get through it, that's a good thing. Well, these might take a while, so yeah, probably won't get through all these, and maybe some of them are pretty simple and they're similar to each other, so maybe we can even feel like we can skip them. Okay, I guess we'll just jump into it. I think just determining whether they open upward or downward, that's fairly easy, you just have to look at it. And then the vertex is simple, but finding the x-intercepts, you have to do a little work, and then finding the y-intercepts, you have to do a little work also. So we might even have to go find like a separate piece of paper or a separate page to just take notes on, just to kind of write out what we're doing to find the x-intercept and y-intercept. Okay. I think, back in chapter 2, when we said, okay, we're going to graph, we used to graph things like this. This guy right here, we said, oh, I'm going to, it opens upward. There's no vertical, what's it called? Reflection. You don't have to reflect it across because there's no negative in the front of the x squared. And then I know how far to shift it. It has a -3. That means it moves down 3. And then the -4 inside means it moves to the right 4. And then this 2 is something about like a vertical stretch or shrink. And it's a lot to remember. And then I guess the thing is now we're like, and when we graph these in chapter 3, we want to be more exact. I don't want to just say, oh, the 2 makes it narrower, so I'm going to draw it narrower. I might be a little bit off. Maybe I drew it too narrow or too wide. I think finding that where it hits the x-axis and finding where it hits the y-axis will kind of guide you to tell you just exactly how wide or how narrow it'll be. So that's why it seems like more work now, because we're getting more precise, I think. That's the idea. Oh, Lord. So I'm going to plot the vertex first. Okay, I know we already kind of talked about this. And number 1, the vertex is 4, -3. So I go to the right 4, down 3. So this parabola U shape is going to start there. So I can kind of imagine what it looks like. But I mean, picture wherever it hits the x-axis, like say if it hits here and here, that would kind of guide me to tell me how wide or how narrow this thing is going to be. I think that's kind of the reasoning behind finding the x and y intercepts. And it's opening upward because we said there's a positive number in front of x squared. The 2 is positive. Okay, so I might have to go and try to figure out what the x-intercepts and y-intercepts are. And I might have enough room off to the side here, but feel free, if you're doing these problems, whatever problems you're assigned for the worksheet, you can always do it on a separate piece of paper or a separate file or something and upload that too if you want. Yeah, but definitely for the problems that you're going to do on these, I want to see your work. So somehow wherever you showed the work for finding the x-intercepts and the y-intercepts, try to upload pictures of that or PDF of that as well if you don't. So I'm gonna, like we said, if you want to find the x-intercepts, I'll set y equal to 0. The equation looks like y equals 2 times x minus 4 squared minus 3, but I'm gonna let y equal 0, and now I have to solve for x. Okay, and it's at first, I think the first time you do it, maybe it's kind of weird, but then you'll notice once you get the hang of it, every problem is the same from here on out. So you're just kind of following the same steps and blah blah blah. So on this one, probably the easiest way to solve for x, I could, if I wanted to, I could multiply this out. I could write x minus 4, because x minus 4 is being squared. That means it's that whole thing, x minus 4 times x minus 4. And I can multiply that out, but I kind of think that might make it harder than it has to be. I could actually isolate x without multiplying anything out. I'm just going to try to remove one thing at a time that's on the right side of the equation and move it to the left. So probably, like we said, when you solve an equation, you want to do it in the reverse order of operations. I'm going to move the 3 over first, just to get them out of the way. And then I'm closer and closer to having x by itself. So 3 would be equal to this 2 times x minus 4. Okay, so now there's nothing adding or subtracting with x. So I'm all done with that stage of order of operations. But if I'm going reverse order of operations, after the add, subtract, the next is multiply or divide. And there is something multiplying or dividing here. There's this 2 in the front that's multiplying. I want to get rid of him by doing the opposite. I'm going to divide both sides by 2. That'll get rid of that guy. And it's not pretty. I got 3 halves on the left side. That's not great. But, what are you going to do? I got x minus 4 squared. Okay. So I've gotten rid of what's adding and subtracting. I've gotten rid of what's multiplying or dividing. Now I have an exponent that I need to get rid of, because that's the next stage in the order of operations to solve. So what's in parentheses is the last thing. I need to move that 4 over very last, because parentheses is at the top of order of operations. So I'll probably try to get rid of that square. All right, what do I need to do? What's the opposite of a square, or a second power, I guess? What do you think? What do you think? If you were finding the inverse, let's say if the one function squared the number, what's the opposite of that? I would need to,
You talking about rooting the number?
yeah, nice, there you go. Nice, okay, we'll take the square root of both sides, okay. Don't, and then I think this is where it's easy to make a mistake or forget something, but I don't know, I can't remember if we talked about this in this math 33, but probably in math 111, you've seen if you were solving an equation and you square root both sides of an equation, the part that just has a number, there's no x involved, like here on the left side, I actually have to put a plus or a minus on that side. Because when you have something being squared and you remove the square by square rooting, it produces two solutions all of a sudden. I think, and you kind of saw that in the quadratic formula, huh? We were reviewing how to do the quadratic formula. So we've seen the plus or minus, but that's why it's there in the quadratic formula, because an x squared or a parabola shaped quadratic guy would have two solutions. And this is where you get them. So every parabola should have two x-intercepts. So, and I think if you end up with one answer, then you know something's wrong. I must have done something wrong because I'm supposed to have two answers. I think this is not going to be super pretty here, but that's okay. In real life, if this were representing something in real life, usually the answers aren't pretty. They're not nice. So the last thing would be now I move the 4 over, and it's not really, these aren't really like terms. I can't really combine the square root of, the square root of 3 over 2 with 4, but at this point, since it's not simplifiable, is that a word? It's not able to be simplified by combining them. Probably what you would do is try to make them into decimals. I'm going to get my calculator, and then just kind of figure out what that is. What is 4 plus the square root of 3 halves? And the other one, because it's a plus or minus, would be plus 4 minus the square root of 3 halves. Those are my two x-intercepts. And yeah, well, how am I supposed to know where that is on the x-axis or the y-axis? I don't know what the square root of 3 halves is, but I'll put it in my calculator and that'll tell me. Get some kind of decimal approximation. 3 halves. Oops. 3 divided by 2, and then the square root of that. Plus, I'll do plus 4 first, and then I'll do minus 4. So I'll do 3 halves. 3 divided by 2 is 1.5. The square root of that is like 1.22. If you add 4 to that, you got about 5.22. Just depends where you want to round, but I think we just want to get an idea of where these points are on the x-axis. Where is this parabola intersecting the x-axis? Okay, looks good. And then the subtraction one, I take 3 divided by 2, and then take the square root of that. Now I'm taking 4 and subtracting that. 4 minus 1.22 is about 2.78 or so. So that it's a lot of work, but that's where this parabola is going to be intersecting the x-axis. Let's see. So back, I'm going to try to identify where those values are on the x-axis back up there. I have that green dot at the bottom. That was the vertex. Now I need to go 5.22, and that's about, it doesn't have to be exact. If it looks like it's in the ballpark, then I'm happy with that. And then 2.78 is probably around there. It's a lot of work. So probably this is too many problems to have you guys go do. And then we still have one more thing to do, the y intercept, but that's the easy one, thankfully. So I'll try to leave that there, all the writing, but the y-intercept, the x-intercept takes a long time. That's the part I dread. The y-intercept, now you're letting x equals 0. So if the equation originally looked like y equals 2 times x minus 4 squared minus 3, I'm letting x equals 0. And then there's no solving that's necessary because it's just the right side will just simplify down to some number, and that's what y is equal to. So it's going to be 2 times, let's see, 0 minus 4 is negative 4. So it's negative 4 squared. And I'll just show that step. Y equals 2 times, let's see. For order of operations, I have to do the exponent first before I multiply or subtract. So I can't do 2 times negative 4 yet. I have to square negative 4. Negative 4 times itself is positive 16. Okay, 2 times 16 is 32. Oh my gosh, minus 3 is 29. Is that right? I think I did that right. Hopefully you would tell me if I did something wrong. Okay, 29. Yeah, that's going to be, where is that going to be? Off the charts, literally off the charts. Did I do that right? 0, 16. Okay. Yeah, I think so. So the y-intercept, you notice that this graph that they gave us, that they provided, only goes up to 6 on the y-axis. So if I was being silly, I guess I could make it go up, 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 and then let's just say that's 29. Whatever. That's fine. Don't worry about it. Yeah, and then I'll try to connect the dots. So the vertex, it'll go up and hit that x-intercept, and then keep going until it hits that y-intercept up there. And then on the right side, I know that I have to go from the vertex to the rightmost x-intercept. And then there's nothing else to guide me on the right side. There's no points, but I know that this parabola is supposed to be symmetric. So I'm going to try to make the right side look like the mirror image of the left side. I'm not doing a great job, but that's okay. It's not an art class. Just do your best, and it's okay. It's fine. Oh, that's a lot of work, right? Oh my gosh. What do you think? And that was only one problem. So how do you feel about it? We can do more. We don't have to do all these together, and we'll probably just cut it off at a certain point. I think probably we could do, let's just call it a day after the first page. Is that okay? I don't want to, I feel bad. You're going to see enough of this in section 3.1 and you're going to get tired of it. Let's just say 7 through 12. Don't worry about those guys. Yeah, maybe we'll try one more as a group, and then we'll have you guys try one and see how it goes. Does that sound okay? Because I think if this is brand new to you and it's probably weird, and it's probably make it more palatable if we go over another example, hopefully then it'll make more sense, and then we'll try one and see how it goes. All right, which one should we try? I'm looking at number 2, and that's not looking, it's not the nicest looking equation I ever saw, or function. It's got that -1/2 in the front, which is kind of, I think it won't be a big problem, but it's not super appealing. So maybe we'll go over that one, and then, you know, as a group, we'll try number 3. Everybody try it, and then we'll compare our answers and stuff. Okay. How about for number 2, based on the number in front of the parentheses, the -1/2, is this parabola going to open upward or downward?
Will it be downward since it's negative?
Yeah, nice, exactly. Yep. So that's, at least there's some things that you just have to look in the right place and you know the answer, you know, the upward or downward, and then the vertex, you know, just by looking at it. But the x-intercepts and y-intercepts, that's a lot of work. Okay, so it's good. I know that at least that's probably the most important piece of information, whether it opens up or down, because I have to kind of visualize this before I graph it. So that's good to know. I'm imagining it being a kind of a downward U shape. Okay. And then what else? How about the vertex now? What would the vertex's x coordinate be?
Would it be 4 and 3?
Yeah, nice. There you go. Good. It was similar to the last one, huh? But so like we said, the vertex, the x value will be just grab the number that's inside the parentheses with x, but change the sign. But similar to the last one, the number inside the parentheses was -4. I take the 4, but I change its sign now to a positive. And then, yeah, like you said, the number that's adding or subtracting at the end is going to be your y value exactly as is. It's positive. I'm keeping it positive. And number 1, it was negative, so I kept it negative. So it almost has the same vertex, but not quite, huh? So I might just plot that right now. I got 4. I'm going to go on this graph to the right 4 and up 3. 4, 3. Yeah, it's about here. Okay, and I'm picturing it as a downward one, so it's going to open downward and probably hit the x-axis 2 times, but exactly where will tell me how wide or how narrow this thing is. So that'll be the annoying part. We'll find the x-intercept and y-intercept. Yeah. Oh, no worries. Yeah. Okay. Maybe we'll go off and I didn't leave a lot of room on this page, obviously. Maybe I'll look at it on that whiteboard thing that we have. Let's see. Here we go. Let me just erase all this. This was just kind of the preliminary stuff, just talking about, I don't know what a parabola looks like. But let me see. I already forgot what our parabola was. What was it? Y? It was -1/2 x - 4 + 3. Did I write that right?
There's an x squared right there, like outside the parentheses.
Thank you. You're right.
Yeah. Almost had it.
I almost, so close. I only missed the most important part. Oh my God. Thank you for saying that. Oh man, that would have definitely messed up the problem if I forgot that. Oh man, thank you for helping me. X-intercepts. Okay. You can find the y-intercept first or the x-intercepts. I don't know. I just do x because x comes before y in the alphabet, I guess. I'm going to let y be 0 and then solve for x. This is the one that takes forever. So, okay. I'm going to replace y with 0. All right. And everything else is the same. And then I'll try to solve for x. But it seems like it's hard or difficult, you know, it's a lot of work, but every one of these is almost the exact same step. So you kind of get the hang of it, even though it's tedious and annoying and boring. Yeah, it's still pretty good. Now, what was I? Hey, what the heck? I lost my. Okay, there we go. Now, I want to solve for x. So I probably need to start moving things over. Like we said, the order of operations reverse. So the adding or subtracting is the last thing in the order of operations. That means it's the first thing I need to get rid of. There's a 3 adding. I'm going to move it over by subtracting. So, okay, that looks good. All right, so far. Then I have -3 equals -1/2 x - 4 squared. Now I need to get rid of what's multiplying or dividing, and that's that -1/2 in the front. And I could, since it's multiplying, -1/2 times the parentheses. I could divide by it, but I think we said a while back that if you have a fraction that you want to get rid of, it's multiplying. The best way to do it is multiply by the reciprocal, which is just that guy upside down. Multiply by the reciprocal of -1/2, which, yeah, I just say, well, what's that upside down? -2/1, or just -2, because that simplifies to -2. So I'll go, okay, -2 multiplied on the right or the left side, -2 multiplied on the right side. And that's good because it's a negative times a negative, and the twos cancel along the diagonal. So there's nothing left in front of the parentheses on the right side. Just be x minus 4 squared. On the left side, I had a -2 times a -3. Now that'll make a +6. I'm glad there's no fraction at this point. On the previous problem, there was a fraction. So this one was actually kind of nice. So maybe having a fraction in the very front of your function for a parabola isn't so bad because it ends up being nice as you solve. So maybe it's not so bad. Now the next thing to do, like on the last one, is I need to take the square root of both sides to knock out that square on the parentheses. But I got to remember, when I square root both sides, whichever side just has a number, no x, I have to put a plus or minus on. So the answer on the left is not just square root of 6, it's positive or negative, plus or minus. And now on the right side, that square root and the square cancel just to leave x minus 4. And I'm pretty much done. Let me see, I'm going to kind of move this equation up to the top because we're running out of room here. Plus or minus square root of 6 is x minus 4, but now I just need to move that 4 over, and I got my two x-intercepts. Positive 4, move it over. Okay, so it should be 4 plus square root of 6 and 4 minus the square root of 6. So for some reason, if in the homework they say, okay, find the x-intercepts of this thing and get, they want an exact answer, they don't say round, then this is probably what they want, these guys. But if you're trying to graph, how am I going to plot? I don't know where that is on the x-axis. I can't find that. So I might do that on my calculator. Square root of 6. I press 6 and then square root button. And now I'll add 4 to that. So 4 plus the square root of 6 is about 6.45. And then the other guy, if I subtract, what am I going to get? The square root of 6 and 4 minus that. Oops. Dang it. I messed up. 6 square root. Oh, geez. Oh, I can't do this. Oh, there we go. Oh my gosh. 1.55. Oh man. So those are approximately what they are. So it kind of depends. If I'm trying to graph something, I probably want to get the decimals because I have no idea where this number is on the x-axis until I see a decimal. Okay, that's about 6.5, and this is about 1.5. But if they say, what are the exact x-intercepts? Don't round, just give me an exact answer. Then they want those 4 plus root 6 and 4 minus root 6. But okay, let me see.
1.55.
Is that
Well, yeah, you're right, but mine turned out to be a negative. I don't know if I input in my calculator incorrectly. I first solved the square root of 6 and then I minus 4. Are you supposed to do minus 4 then square root of 6?
Oh, that's a good question. I think you probably want to do 4 minus the square root of 6, but if you have the square root of 6 on your calculator, you probably just I would do, okay, 6 square root is about 2.45 or so. If you just do the square root of 6, and then I'll subtract those on my calculator, clear it and start all over. 4 minus 2.45. Yeah, I think that's how you'll have to do it.
Okay, thank you.
Yeah, you're welcome. Good question. Sometimes when you're calculating something on your calculator, you have to do it kind of a piece at a time like that. Like the 4, okay, the square root of 6 is this 2.45. I kind of write that down, and then I have to start over on my calculator. 4 minus that thing. I think unless you have a really big fancy calculator, it can probably handle that whole thing at once. You can just type in 4 plus square root of 6 or 4 minus, and it'll do the whole thing. But if I think if you're using your phone or a basic calculator, you probably have to do it in stages because the calculator is not smart enough like we are. It doesn't know. Yeah, and you probably don't want to invest $100 on a calculator as well. I guess unless you're going to have to go really high in math, then maybe it might be not a bad idea. Ask for it for Christmas, huh? There you go. Or your birthday. Is that a really lame birthday present? Maybe. Anyway, all right.
If you're into math, it wouldn't be bad, but I wouldn't want that.
If you open it, your present, you see that, you say, what the heck? Are you serious? Is this a joke? Is this a prank? Oh, that's funny. Yeah, if you're really into math, then you might be oh my gosh, that's what I always wanted. Maybe not. Jenny said she asked for one for Christmas last year. That's awesome. Okay, so I'm not the only person that would do that. That makes me feel better. Okay. I don't know if I left room in here, but we took all this room to find the x-intercept, so I could plot those two right now on the x-axis. Let me see if I can fit the y-intercept in there. The y-intercept you're supposed to find by letting x equal 0. Okay, so I'm going to go back to this original guy and let x equal 0. Y, I'm going to keep y -1/2 times 0 minus 4 squared plus 3. That's going to be weird. So, okay. What do we have? -1/2 times, okay, 0 minus 4 is -4, and -4 squared is 16. So I'm going to go just that's 16 plus 3. And then how about what's -1/2 of 16? Well, I could put the 16 over 1 and kind of reduce a little bit along that diagonal. I got 2 going into 16. It'll leave it 8, but it's negative, so it's going to be -8 plus that 3 that was there at the end. -8 plus 3, -5, I guess. That's where it's this graph is going to hit the y-axis. Oh my gosh. So maybe that -1/2 that was in the front, it hasn't bothered us yet, but at this point it's kind of bothering me because that was not fun to have to calculate that y-intercept. Yeah, just let the x equals 0 and then simplify the right side and you're done. So let me see if I can remember that. I got those. So I want to move back to the worksheet now. So x 6.45 and also 1.55. And now the y value is -5. Let me see if I can remember that. Come on, memory. I believe in you, memory. I probably shouldn't. All right, I think we're back. So was it 6.45? I think was one of them. Wow, so it's off the charts over here. That's okay. And then the other one was, oh man, I already forgot. What was the other? No, 2.45 or something. Is that right?
It was, I think it was 1.55.
Oh, thank you. That's right. Thank you. That's pretty bad. That's how you know you have a bad memory. Just looking at it 2 seconds ago and I already forgot. Wow. But that's, I guess, what's that?
And the y is a -5. If you
Oh, that's right. Thank you. Okay. -5. And it's off the chart. So I got to just kind of, I guess I can extend it. And I'm just going to say, let's say that's at -5, whatever. I think you probably know you did because the hardest part of this whole process is finding the x-intercepts. I feel like I can make a mistake somewhere in there, but it's a good sign that this thing, it looks like it's symmetric about that vertex. You know, if I think about a mirror being right down there at the vertex, it does look like the left and the right side are mirror images of each other. Like those two x-intercepts are the same distance away from the vertex, at least horizontally. You know what I mean? Like this distance here is the same as this distance here. That's a good sign. That should always be the case. If you plot your x-intercepts and that's not the case, that they're not the same distance away horizontally from the vertex, then probably something went wrong. But I think that looks good. I'm glad. It looks like we did everything right. Now I just need to connect the dots. This is like, if you like baseball, you hit a home run, now you're just rounding the plates. This is my home run right here. Yeah, and everybody's cheering for me. Yeah, you draw such a good parabola. Thank you. Is that a good metaphor? It makes math seem more fun than it really is, hopefully. Okay, man, yeah. Looks about right. I was just noticing that, like on the last one, the left side, I kind of know what it's supposed to look like, how wide it is, because the first x-intercept and then the y-intercept is kind of guiding me. The right side, I don't have as much guidance, but I'm just trying to make it look like a mirror image of the left side. This is whatever. It's close enough, close enough. Okay. How do you feel? Do you have any questions about those two? It's a lot of work.
I think we're good, hopefully.
Yeah, okay. I think it takes a lot of practice because it's just, if you haven't seen it before, it's just so much to remember. How do I find the x-intercepts and how do I do this thing? Yeah, but how about we'll try this one. Maybe I'll break us into groups and we'll try it. I know everybody hates that, but if you want, just maybe you could be in a group. You don't have to talk right away. You could just kind of be individually working on it and then compare at the end. Like, oh, hey, you're done. So what did you get for the x-intercepts? What did you get for the y-intercept? Yeah, okay. I'm going to start the breakout rooms. You just have to do number 3, but if you end up having extra time, you can always try more if you want. I'm going to try, yeah. Okay, let's see. Okay. Oh, well, hopefully, yeah. At least all the writing's here, huh? Extra credit for that one, extra credit for this one. And then we already said you don't have to do the last page. And I was thinking, because everybody, I want to say I appreciate everybody that shows up to these Math 33 meetings, because I know our class has like 30 something people in it, but only 10, 15 people show up to these. So I'm going to figure these answers out, number 5 and number 6, and I will send just the people that showed up to this meeting the answers, so you can check your answers and get extra credit for it. But nobody else, because they don't want to show up, you know what I mean? Does that sound good?
Yes. So
Yeah.
just do the bottom two or just question number 6 for extra credit?
Yeah, 5 and 6. I think right now we're probably just in our last 10 minutes, we'll go over number 4 altogether, you know, and then we'll say, okay, that's it, all done. And if you want to, you just have to really upload the first 4 problems and then you're good, you can be done. But if you want extra credit, you can do number 5 and number 6 and add those onto your worksheet or whatever. But I'll send you I'll email just the people that are in this meeting the answers, just like what are the x-intercepts and stuff and what's the vertex, just so you can check your work and you'll make sure you get all the extra credit. Yeah. I appreciate you all showing up to these Zoom meetings. I know they're not fun. No one wants to wake up on a day they don't have to and listen to some math. Oh my gosh, that's the last thing you want to do. So I appreciate that. Thank you. I don't even want to listen to myself, honestly. Okay. So I think we can go over number 4 together if you don't mind. I think it's kind of similar to the last one. You know, number 4, you notice there's no number in front of the parentheses. It's just a 1. So it's going to be kind of similar, but at least hopefully it'll make it more concrete. And then number 5 and number 6 for extra credit will be easier. And I'll send you the answers. So anyway, number 4, do you think number 4, is that parabola going to open upward or downward? Well, maybe it's too easy. Everybody knows it's going to open, yeah, upward, kind of like the last one, huh? Because there's no number in the front. How about the vertex? Okay, I'm going to give it a second. Vertex. What do you think is the x coordinate of the vertex? Yeah, nice. Okay, someone said -2 is the x coordinate because like we said before, you grab the number that's inside the parentheses with x, but change the sign. Since it was a +2, I'm going to put a -2. And then for the y coordinate, I grab the number that's adding or subtracting at the end and don't change the sign. So it should be both negative because I had to change the +2 to a -2 and the 4 remain negative. All right, so we got the vertex. That should be, I'm going to go left 2, down 4. It's about here in this little corner here. All right. And it's opening upward from there. Okay. And I just got to figure out y-intercept and x-intercepts, and then I'll be all done. X-intercepts. All right. That's where I'm going to set y equal to 0. The function that was given, y equals x plus 2 squared minus 4. But I'm going to let y be 0 and then solve for x. I think this one we might actually get nice numbers. We got lucky on this one. So if I want to solve this for x, I would move the 4 over first. I'm going to go do that. Okay, now I have 4 is equal to just the x plus 2 squared in parentheses. And then to get rid of the square, like we've done before, yeah, this becomes second nature as you do it over and over and over. I'm going to square root both sides. Just don't forget the plus or minus on the 4 root. This is the first time, I think, in this worksheet anyway, that we've seen a square root that actually has an exact square root, because 4 square root is just 2. So the left side, I don't have a root anymore. It's just 2, positive or negative. And the right side, the square root and the square cancel. All right, and this one, it's almost like if there's a root, I know what to do, but now that there's no root, it's almost like I don't know what to do now, because this -2 that I'm moving over can combine with that positive or plus or minus 2. But just to be safe, I need to break it into cases. Now I have x by itself. It should be equal to this right here, -2 plus or minus 2. Or you could have written it backwards, the plus or minus 2 was already there, and then I subtracted 2. Whatever you want to call it. But before I can't combine those right now because that really represents 2 different answers. I'm going to break it into its cases. In one case, x is equal to -2 plus 2, because I'm doing the positive version of the plus or minus. But in the other case, x is equal to -2 minus 2. Then I have to simplify from there. Okay, -2 plus 2 would just be 0. And then -2 minus 2 would be -4. So that's kind of nice. My x-intercepts are nice whole numbers. I like that. That's the goal, I guess. So I could plot those if I want to, but yeah, I might plot them right now. X equals 0 back on my graph would just be where the x and y axes meet. Okay, 0. And then x equals -4 looks like it's about here. And I'm thinking that those 2 points, they look like they're equidistant from the vertex, at least horizontally. So I'm probably doing good so far. And then the very last thing would be find the y-intercept. But that's where I let x equal 0 and then see what happens with y. Y it was equal to, for this one, x minus 3. Oh wait, x minus 3. No, that's the one you're doing for extra credit. This one's x plus 2. Oh my gosh. -4 squared. All right. So I'm letting x equals 0, y equals 0 plus 2 squared. That's 0 plus 2 is 2 squared minus 4. So that's 4 minus 4, which is 0. So this is a weird one. I'm glad we got a chance to go over this one, just because it's strange that now we actually usually we get 4 points. The y-intercept is 1 point, 2 more x-intercepts makes 3 points plus the vertex. This time though, the y-intercept, one of the x-intercepts is the y-intercept. So you really only have 3 points, but that's okay. I think on the homework, if you were to graph these, they only need 2 points. So you just maybe find the vertex and then an x-intercept. That might be worth mentioning on the homework. This is for section 3.1. You need to plot the vertex first. Okay, you just plot the vertex and then any other point, and you can choose an x-intercept or y-intercept, whatever you want. Yeah, and then it already knows what the parabola will look like. Whew. What do you think? How do you feel about that one? That one's kind of weird because it didn't go exactly the way it did before. You know, the root here at this point became a whole number that felt kind of weird, and then combining these was kind of strange. So, and then the fact that your y-intercept was already on your graph because it was an x-intercept, but it's not a big deal. Now we know it's not that bad. Oh, I'm all done. Okay. We're going to have those 4, of course, the first 4 problems, that's what you need to upload for your answer here, whether it's on this worksheet or on a separate piece of paper, photographs or scanned document, whatever you want to do. But number 5 and number 6 are extra credit. And I'll send you the answers, the x-intercepts and the y-intercept and the vertex. So you can just check your answer that way. Okay. Anybody, do you have any questions? If you don't have any questions, then you're free to, log out and upload or wait till I send you the answers. But have a good weekend if I don't talk to you. But please stay and ask questions if you have any.
Thank you, Professor. Have a good one.
Thanks. Have a good one. We'll talk to you on Tuesday. Have a good weekend.
I will, you too.
Thank you.
Bye-bye.
Bye. Thank you.